Hello, everyone. My name is Abdurrahman, and today I'm going to talk about XAI, or Explainable Artificial Intelligence. Okay. Just a quick introduction. I work in the banking sector for about 8 years now. I work in the data and AI field. Okay. And this is not an X-Men movie or Wolverine movie. Okay, so the motivation behind this talk is that, as I said, I work in the AI and data field within banking sector, and implementing the stuff in the real world is actually very, very hard. It takes many months to implement an AI machine learning model in production, and it takes even longer to convince other people to actually use it and make it live for people to use it. On a personal level, I feel drawn to this field, XAI, and I never really liked the blind reliance of AI by people around the world. So this field, XAI, is a field that is in active development, and since AI also is under scrutiny by regulators everywhere. Okay, so the agenda for this talk is that I will explain to you why XAI is important, and then like a general overview of the techniques. And then we'll go over a specific Python package called SHAP, which is used for explaining your machine learning model. So first of all, why is it important to explain machine learning or AI? So I'll give you here like 3 examples. They're all in the US. The first one is racism embedded in the US healthcare. So in 2018, researchers found that the algorithm used on more than 200 million people in the US hospitals to predict which patient would likely need extra medical care. It favored white patients over black patients. Okay, so this is one example of AI bias. Another example is in the US jurisdictions system, basically jail. They had a system that tried to predict the repeat offenders. And as you can see here, it predicted twice as many false positive for repeat offenders for black offenders than white offenders. Okay. Another example is the Amazon hiring algorithm. In 2015, they realized that it was found to be biased against women, since most of the, let's say, data that was used to train this algorithm or machine learning was basically, you have most of them male applicant to Amazon. So it was biased towards male rather than female. Okay. Another thing that I came across recently is that AI is being used heavily now within, let's say, by employers for the screening process and interviewing and everything. So this is one company called Jobs that says that just a 90-second Zoom call generates up to an 18-page talent report. So basically it tells you like the profile of the candidate and everything with just 90 seconds. And there's this guy called David Stilwell, and he did his research on this. He's into psychometrics, which is like data-driven psychology. So he did this on multiple, let's say, research objects or samples. And the way that he does it is basically he asks the question, like, tell me about the time you had a month or more to prepare for an important presentation. Or tell me about the time a close friend or coworker reached out for help while you were busy. And these kind of things actually, they are used by companies on an automated basis. So the candidate will go in, there's like pre-recorded questions, and he needs to answer, and the software will analyze everything. And in that manner, the company gets to interview like hundreds of candidates instead of like one at a time. So it's very useful for the employer, but as you will see, it is used by AI. It's embedded in AI for for profiling the candidates. The types of features that is, let's say, red is, for example, here we have language-based, audio, and facial expressions. And the key takeaways from this is that it's actually really good at predicting the personality of the candidate, almost to a human level, okay? And when they did the research, they found that the most important features are the words that the candidate is saying. So not, let's say, the way that they say it or the facial expressions. And he did it in two manners. One, what we call is a glass box model. One is a black box. Black box meaning it's a very complicated machine learning model that really difficult to interpret. Glass box is, let's say, a machine learning model that is easy to interpret and see why it predicted this way rather than that way. So this is just one explanation. So he says here that the predictions from the explainable model, for example, we found that if there is a religious language, then it is correlated with low openness, basically negative relationship between openness and religiosity. While high openness means more words related to secular enlightenment and artistic interest and intellectual activities. So this kind of, let's say, explainability into the model, you wouldn't get unless you have like a glass box model or you apply some interpretation methods on the model for you to know. So I'm just wondering that if we get this applied here directly, and the candidate said, for example, inshallah, or الحمد لله خلينا نقول توفيق خلصنا البروجكت, يعني would that be correlated negatively towards openness or not? Just a thought. And there is a push from regulators, for example, here in the US, we see that people with disabilities have like twice the unemployment rate than normal people. So the US is pushing towards having well-regulated usage in AI and when it comes to the employer and applying to candidates, just not to break any laws. And another one from the EU is that the GDPR, the data protection regulation, they mentioned that meaningful information about the logic involved, the right to an explanation, and so on. So there is a push from regulators towards explainable AI. We don't want anymore, let's say, black box AI that gives you a decision and then go ahead with it. And also in the medical field, where it is extremely important. Okay, you have like lots of research about this, and only a few gets approved, and most of them are in the radiology. Okay, so just a general overview of this. I think I will take the 5 minutes for questions. Just a general overview of this. As we mentioned, we have two types of models, glass box and black box. And there is usually a trade-off between interpretation and performance of the models. So simple models are interpretable, meaning you can see basically why they're making a prediction. While complex models are not, but they are high in performance. Okay, meaning, let's say, the accuracy and giving good predictions. And unfortunately, there is a tendency from data scientists or AI practitioners to fixate on model performance rather than explainability. And you see that even in, let's say, in the competitions that we have on Kaggle, etc. The top, let's say, model is the one with the highest accuracy and so on, okay? There is no really focus or highlight on the explainability of the model. So what are some desirable features for XAI? We want the model to be fair, meaning basically what drives model predictions. We want it to be accountable, meaning why did the model take a certain decision? And you want it to be transparent, basically how can we trust your model predictions? These are some general features that we want. Some methods for, let's say, categorizing the different methods for interpretation for the models. You have what we call intrinsic versus post hoc. Intrinsic meaning the model itself, the machine learning algorithm itself is explainable, okay? So for example, here we have a decision tree, which basically tells you if this, then that, then basically the prediction is this. So this is very interpretable by its nature. There is a post hoc methods where basically you will build your machine learning model, and after it, let's say the next step is you try to explain the behavior or predictions. There is also another, let's say, type of categorization where it's model specific versus model agnostic. Model agnostic, meaning that this interpretation method can apply to multiple machine learning algorithms and models. There is also what we call local versus global, meaning global meaning you explain the whole model, the whole, let's say, predictions. Local meaning if you have a sample prediction, you want to explain it why exactly that happened. Okay. And some traditional methods for the explaining for machine learning is an EDA. An EDA is basically an exploratory data analysis. It is a required step before you build the model, so that when the model, let's say, predicts in a certain way, you know basically the correlations between the different features and the target variable that you're trying to predict. So for example, here, this is just one automated tool. It's called the Pandas profiling tool. You have data here for the US Census Bureau. You have the age, etc., and everything. Let me zoom in. And you have the at the end the class basically was this person is making less than 50K or more. Okay, so this is just the data in a nutshell. So this type of profiling tool tells you basically that you have 15 variables, you have this many observations, you have missing cells, you have duplicate rows. It tells you here, for example, that age is highly correlated with marital status or different kind of correlations. And you can see for each variable one by one the different, let's say, distribution of the data. And you can also, for example, for the age, you can see different statistics, the median, mean, min, max, etc. Okay, so we get to step into each variable on its own. And also, you get to see the correlation matrix for the entire, let's say, variables. For example, here you have the class, which is the person making more than 50K or less than 50K. You can see easily that it relates to relationship and education and age. Okay, so this is one way of doing it. Another way of doing it is basically you stepping in actually and do some coding, and you see the different variables and etc. For example, here you can do different, let's say, cross tab and see the different variables, how do they interact with each other against the class variable and everything. And you can do even a quick, let's say, decision tree, a basic model, and you can see how the, let's say, a simple model would behave, and you get to know your data better. Okay. The second, let's say, cool method of doing it for explaining your machine learning model is basically using the machine learning algorithm, for example, neural networks, to develop a black box model, and then you build what's called a surrogate model, which basically tries to maps the prediction from the black box to developing a decision tree. So this is just, can you interpret machine learning models? Yes, just use more machine learning. For example, this is the steps. I won't go into them here, but at the end you have the black box model, and then you end up with an interpretable machine learning model. Maybe it's not as performant as the black box, but it is similar. And the trade-off is that it is more interpretable. The tool that I want to highlight here, last thing, is Chat, something that I had to use for work recently. Okay, so this tells you that you have your input data, and normally, let's say, it gives you an output of, let me zoom, gives you an output of 0.4, and this tells you actually where did that 0.4 came from. So the base rate, which is like the mean across all the observation, is 0.1, and then you have this variable pushing here, this variable pushing here, this variable pushing here, this variable pushing here, and then you end up with a 0.4. Okay, so this gives you an explanation of your machine learning model. And one chart here that I want to show is this one, which gives you basically all your features with the feature importance and everything. And you can see here that this variable, if it is high in value, then it predicts, let's say, towards the opposite of your prediction. If it's low in value, actually, it contributes to your positive prediction, and so on. So this chart is like a summary chart that gives you an explanation of your machine learning model. And this applies to everything or lots of things, not just tabular data. It also applies to, let's say, image data. And also here they have some text examples and genomic examples and everything. Okay, so this is just one thing that I had to use recently at work to explain my machine learning model and make it acceptable to be used for other people. That's all.